Hello guys, welcome back again to another video of your class 11 mathematics. So in today's video again we're going to study your chapter 7, most particularly your exercise 7.4. So let's begin. So your exercise 7.4, it's all about the topic known as your combination. Okay, so combination, it means each of the different groups or selection which can be formed by taking some or all of a number of object irrespective of their arrangement is called combination. Okay, so before I go with an example, in your previous video I have already given example for permutation. So let me just take the same example. Your A, B, C, and I said make a two-letter word. That's only for permutation. Okay, and we got it to be AB, and I got it to be AC, I got to be BC, CBE, CA, and then I can say BA. And similarly, your three-letter word, the example happens to be ABC, ACB, BCA, CAB, and I can go with one ABC, ACB, BCA. Just wait for a while. CAB, CBA, and then BAC. That was for permutation. But the same example, if I happen to give in your combination, and I say that make a two-letter word, right? So ABC, so it will be your AB, BC, and then your AC. Stop. And similarly, make a three-letter word. That will be nothing more than your ABC. All right. From these two examples, from a permutation and combination, what we're clear is that in permutation, digits, number, alphabets, anything can be repeated. But in combination, nothing are to be repeated. Okay, if you can see, I got AC and there is CA, so nothing to be repeated. And for permutation, I got so many, but from here I got only one. All right, now let me just give you theorem of how to denote and note your combination. So I can just say that for your notation, your combination is nothing more than your, again, N, C, R, and something 0 less than equal to R less than equal to your N. And I can say the number of all combinations of and distinct objects, taken R at a time is given by NCR is equal to your N factorial divided by R factorial, and then your N minus R factorial. Okay, second thing that what you have to know over here is that, as a note, number one is your NC0 is equal to your 1, and also number two is that your NC N minus R is equal to your NCR. This one is quite important, so when we do the sum, we'll know how to use this one also. Then what can I do more? I can go for your, let me go number 3. It's always remember that your NCA is equal to your NCB if your A is equal to B, or your N is equal to your A plus B. And what more can I go? And also I can go with this one, your NCN. So your NC0 and your NCN happens to be both 1. Yeah, so lastly, I can go with the point number 4. For the point number 4, I can say that your NCR plus your NCR minus 1, it's nothing more than your N plus 1 CR. Yeah, I can go with your point number 4 with that. So every points are important, so don't forget this one. That's the basic formula for your combination, and the first point is that. The second point is very much important, and comes your third point, then lastly fourth point. Okay, so let me directly begin with the exercise then. Okay, so let's start with the exercise. Your exercise 7.4, nothing more than your question number 1. Question number 1 is given that if your NC8 is equal to your NC2, find NC2. Okay, so let me go with a note. I'm going to apply this formula, point number 3. So if I apply the formula, point number 3, let me just write down that it's NCA is equal to your NCB. It implies either A is equal to B or N is equal to your A plus B. So here I can say, here, it will be either your 8 is equal to 2 or N is equal to your 8 plus 2. So your 8 is equal to 2, it's impossible, so this one is nothing more than your rejected. So the value for N, I got it to be 10. So therefore, your NC2 is nothing more than your 10C2. Now, as I said, this formula is very much important. Your NCN minus R is equal to NCR. So similarly, using that, or I will just try to solve it in a very easy manner. Your 10C2, you can apply the formula, which is nothing more than your NCR is equal to your N factorial divided by R factorial and then your N minus R factorial and solve it. Or you can do in easy manner also, like shortcut, okay? How? Just see how I'm doing. Your 10C2, always look at the value for down. I got how much? 2. So factorize 10 till you get 2. So it will be 10 into 9. And similarly, 2 means 2 into 1. So which is nothing more than 9 5s are 45. So that's your answer. If you want to apply this formula, same thing, let us try. I'll get here 10C2. It means 10 factorial divided by 2 factorial. And I got here 10 minus 2 factorial. So 10 minus 2 is 8. So factorize 10 until you get 8. 10, 9, 8. And similarly, 2 into 1 and then into 8 factorial. You can say 8 factorial, 8 factorial, same thing, 2, 10, 5. So I got the answer to be 45. So both are correct only. So do remember, always try to do an easy manner all the time, like this one. Okay, so it's okay. We'll learn later on, more question to come, so doesn't have to hesitate over here. So that was all about your question number 1. So let me do your question number 2 then. Your question number 2, it's given that determine N if 2NC3 is to your NC3 is equal to 12 is to 1. So let me just divide into two groups first. So the first one, let me just try to do it. I got here 2NC3 divided by NC3 is equal to 12 by 1. So using the formula, there will be 2n factorial divided by 3 factor, and then your 2n minus 3 divided by n, and then 3, and then your n minus 3, and which is equal to 12 by 1. So I can cancel this with that. And do remember, I cannot cancel like this, okay? 2n factorial and then your n factorial. I cannot cancel n factorial and factorial. Why? Because these are totally different. So don't forget this one. So if I happen to solve, I'll get the answer to be, I got 2n factorial divided by 2n minus 3, and something I got here, n factorial divided by your n minus 3, which is equal to 12 by 1. So your 2n factorial and 2n minus 3, between these two, between this and this one is greater. So similarly, between this and this, your n factorial is greater. So if I factorize 2n, I'll get the answer to be 2n, 2n minus 1, 2n minus 2, and then 2n minus 3 factorial divided by 2n minus 3 factorial, and similarly n minus 1, n minus 2, n minus 3 divided by n minus 3 factorial is equal to 12 by 1. Now we cancel this with that, and this with this, and similarly I can cancel n. From here, from this one I can take 2 common. Okay, so I'm going to take 2 common, so the answer will be 4, and 2n minus 1, I'll get here n minus 1 divided by n minus 1, n minus 2 is equal to 12 by 1. So I can cancel n minus 1, n minus 1. So if I multiply, I'll get here 8n minus 4 is equal to, that will be 12n minus 24. So which is 8n minus 12n is equal to minus 24 plus 4. So I got your answer to be 8n minus 12n is nothing more than 9, 10, 11, 12. Yes, minus 4n is equal to, I'll get here minus 20. So I'll get minus minus cancel, n is equal to 5. Yeah, so that's all about your question number 1. Okay. All right. So let me again jump ahead to your next question. So your next question is given to be, let me go with your question number 4, is given how many ways can a team of 3 boys and 3 girls be selected from 5 boys and 4 girls? Okay, so we have to form, we have to form a team out of 5 boys and 4 girls. So we have to form a team out of 5 boys and 4 girls. Okay, so since 3 boys are to be selected from 5 boys, so number of ways would be nothing more than your 5c3. And also I have to 3 girls here, 3 girls are to be selected from 4 girls, so number of ways would be nothing more than your 4c3. So therefore, by fundamental principle of counting, total number of ways of selecting a team is equal to 5c3 into 4c3. Now only I'm going to apply that point number 2, which was given to be nc n minus r is equal to your ncr. So what do I mean by it is that just look at your what do you call value for r. I got here 3 and I got here 3, and just look the n. If it's a little bit closer, don't have to subtract it, but if it's a little bit far, just subtract it. Okay, so if I happen to use this one over here, what do you mean by far and near? I'll just learn to know now only. So I got 5c3. 5c3, it means I can go for 5c 5 minus 3, and similarly 4c3 means 4c 4 minus 3. So, okay, let me just write down nicely again here. I got here your 5c 5 minus 3 and to 4c 4 minus 3. So if I happen to do that, I'll get the answer 5c2 into 4c1. So it means 5c2, you can just simply go with 5 into 4 divided by 2 into 1, and your 4c1 will be 4 by 1. So if I cancel, that was 2. So answer is 40. Okay, so that is how to be done using this formula. So this formula is handy only for bigger terms. This one is very small, but I have used this formula in order to show how to use this formula. And you don't have to worry, later on some questions will be there which is a bit tougher. From that we're gonna learn from that question itself only. So okay, let me go ahead with the next question. Let me just go with your question number 6. Your question number 6 is given that determine the number of 5 card combination out of a deck of 52 cards if there is one ace in each combination. Okay, I can just say that in a 52 deck cards, there are 4 ace of different color or different combinations, same thing. So I have to find a 5 card combination out of 52 cards if there is exactly one ace. So there should be exactly one ace. So what can I do? Then I can simply say that one ace one ace is to be selected from the 4 ace in nothing more than your 4c1 ways. So I remember that 4 ace is gone now. If 4 ace is gone, that means I have to remove this. I'm going to start a different pen. If 4 ace is gone, that means I have to remove from 52 4 cards, which will be nothing more than your 48. So what can I say with the next line is that then the remaining 52 minus 4, which is equal to 48 cards. Then the remaining 42 cards are to be selected for the remaining place, that is 4 place, because 4 place remain. I have to find 5 card combinations, so 4 place remain 4. So this is 4 place in nothing more than your 48c4 ways. Okay, so that's how we have done till now. So what can I do with the next one is that hence by fundamental principle of counting, total number of 5 card combination that can be formed if there is exactly one ace, that will be equal to, I got here 4c1 into 48c4. So what can I do is 4 divided by 1 into 48, 47, 46, 45 divided by 4, 3, 2, 1 items 4 and 4, 2, 24, 3, 8. So if I multiply, I will get the answer 778,320 ways. So that's your answer. Okay, so that's all about your question number 6. So let me go ahead and do the next question. Let me just go with question number 9. Question number 9 is given to be, in how many ways can a student choose a program of 5 courses if 9 courses are available and 2 specific courses are compulsory for every student? Okay, if I have to give this one as an example, just think that I've got 9 courses available, out of which I have to choose nothing more than 5 courses, where 2 courses are compulsory. So if 2 courses are compulsory, it means these 2 courses are compulsory even from 9 and even for 5 also. So in short, your combination would be nothing more than your 9 minus 2 C 5 minus 2. Why is that so? Because both the courses are compulsory for everything, for 9 also, for 5 also. Okay, and if I have to write on this one in a wording, I'll just say that question 9 solution, since there are 9 courses available, out of which 2 courses are compulsory for every student. Courses available, out of which 2 courses are compulsory for every student. Therefore, the student has to choose from 5 minus 2 equal to 3 courses out of the remaining 9 minus 2 is equal to 7 courses in nothing more than 7C3 ways. So if it's 7C3, that means 7 into 6 into 5 divided by 3 into 2 into 1. I cancel this one. The answer is 35 ways. So that's all about your question number 9.